Welcome to the Fire Sprinkler Podcast with Chris and Logan.
Hey everyone, before we get started on this episode of the podcast, I wanted to let you know about an event I have coming up at Seneca College in Toronto. The 9th Annual Career Fair and Industry Dinner will take place at the college on March 12th. It's a great opportunity to meet some of the future rock stars of the industry that Seneca has been pumping out lately, and hopefully snipe some of them up and add them to your design team before they get away. A lot of my guests on the podcast are Seneca grads, and it's pretty rare nowadays to get a designer who didn't come from Seneca's Sprinkler Design Program. I did the online program back in 2012. I love what the college is doing for the industry. Reach out to Scott Pugsley. He's the industry coordinator and a professor at Seneca College if you have any more information. If you have any more questions. This isn't an ad. I'm just helping getting the word out for the event. It's a good event. If you're interested in coming on the podcast and you're going to be attending the event, drop me a line, Chris at Fire Sprinkler Podcast, and let's set something up and talk sprinkler. This episode of the Fire Sprinkler Podcast is my conversation with Jonathan Roger from FireFlex. FireFlex is the company that developed the Vactech system. The Vactech system is a dry sprinkler system that operates under a vacuum. I was curious about the operation of the system, and I've been trying to get somebody from FireFlex on for a while now to discuss how the system works and how they got listed. I also wanted to find out why we should use vacuum pressure as opposed to positive pressure, which is pretty much the industry standard across the board. And they finally caved. So, without further ado, here's my conversation with Jonathan Roger from FireFlex. Jonathan, how are you today?
Very good, thank you.
Before we get started about talking about the FireFlex system, why don't you tell me a little bit about yourself and what you do with FireFlex?
Well, for FireFlex, I'm the general manager at FireFlex. I've been with the company for 16 years now. Started out in R&D, working on compressed air foam systems, special hazard systems, and then moved on to engineering, and now the general manager now.
General manager. Okay, so you're kind of involved. You're kind of responsible for everything that happens within the FireFlex brand now, essentially, huh?
That's correct. Yes, for it's been 2 years now. So yeah, everything that happens here it goes through my desk.
No, that's awesome. For the positive and the negative, I'm sure.
That's correct. Yeah.
So the reason we linked up, I've been trying to get FireFlex on for a long number of years now. I'll borderline say harassing you guys at every trade show I've seen you guys at. And I've finally been able to get you guys on because you guys have a product out that you guys have been kind of teasing for the past couple years. And it was released, was it about a year ago you guys finally came to market with it?
Yeah, it's actually been probably 2 years that we brought it out to the NFPA for the first time. And so, yeah, we've been talking about it now we've been working on it for a while, but since 2 years now, it's been launched at the NFPA, if you will.
So the product that we're talking about is the FireFlex Vactech system. And what this is instead of using positive pressure in a dry system, you guys have essentially figured out how to use negative pressure or a vacuum in a dry system. So first of all, very, very, very inventive product. I like talking about new products in the industry. Where did this product come from? Who came up with who was the first guy to raise his hand at the board meeting and say, why don't we put negative pressure as opposed to positive pressure in a dry system?
Well, actually, we can't take credit for that. It actually came from a company out of in France. Actually, many years ago. I'm actually going to say 25 to 30 years ago. Actually, came up with the concept of putting vacuum in a sprinkler pipe. And back then, actually, they had approached Viking Corp about this solution, saying, "Well, maybe we have an idea." Because back then, the idea was that everybody was there was a race to see who could get water to the head the fastest, and so the idea of the vacuum was just for that. It was like, well, creating a vacuum would help bring water along quicker and get to the furthest sprinkler head. And FireFlex, even back then, about 25 years ago, we got also invited to this test series that was done at the Viking headquarters to do some testing with this company from France to see, what it was all about and what we could do with this. So back then, when they did the tests, the results were a little inconclusive about water delivery because depending on, today we know differently, but back then they did some tests and they realized, it's not much faster, so they kind of kind of dropped the idea back then to pursue this. But today we know that the piping configuration plays a large part in that, and that some cases it can be faster, some cases it won't be faster, and we can get into that. But the idea came a long time ago, but back in 2013, actually the same French company, which is called Vactech, approached FireFlex again to see if we could help them out with this technology. And this time around, it was a bit different because in 2013, corrosion became more of an issue with in the piping, and nitrogen started showing up more and more. So now, instead of just being about getting water faster, the advantages of the vacuum was on looking at corrosion now as a corrosion mitigation measure. So we decided to take another look at it in 2013 with them, and decided that this has more than one application now, or more than one benefit, and that I think the market would be ready for something like this. So we kind of went through and then started working with them back in 2013.
So when the studies and everything like that back in prior to everybody, the name of the game was to get water to the sprinkler the fastest. Everybody kind of accepted fate and decided, you know what, there's really nothing we can do about getting the water faster. Nowadays they have a low pressure dry systems, things like that. The getting water to the faster isn't the priority more. We've got these dry systems that have been installed for 16 to 22 years now is almost the average lifespan for dry pipe systems. What else can we do to mitigate corrosion?
Yep, and that was pretty much I think now that's where people are talking about a bit more, and obviously some systems even fail quicker than that. So I think now that's more and more, over time, I guess statistics have shown that there's been a lot of issues with dry systems over the years. So it was trying to find a solution for that. And now with the vacuum technology, I think we have another option out there to mitigate corrosion. So we do have hydraulic benefits, obviously, with the Vactech as well. But again, it wasn't like back in the day where it was really just about speed and getting it there. So nowadays we have vacuum is a good way for corrosion.
So in 2013, they approached you guys again and said, "Hey, we want to take another stab at doing these vacuum dry systems. Jump on board. This is what we want to do." What were some of the issues once you started making the proposals and putting the things together? What were some of the holdups within the industry as essentially, even at that point, it was all positive pressure dry systems. What was the feedback and what was the general kind of general response to the idea of a vacuum dry system?
Well, I think some of the responses that we've gotten were more about, some people looked at this in the past, and I think the hardware wasn't quite there, and that was one of the main things. I remember somebody telling me they had seen some vacuum systems, and all these parts that people didn't recognize were kind of being used but we normally didn't use in fire protection. Because the company in France actually did have their own kind of system that they didn't get it approved. They had local approvals only, and so they were using components and wiring and panels and all kinds of stuff that weren't approved for fire protection. So the system did work in a few places they installed it, but the idea was viable for sure. But it was more, when it came to us, it was more to get help as well. Let's say we want to mass produce this, we want to get all the approvals for these from different agencies to get into the North American market. And that's where they kind of came to us for help in those respects. So we had to take the system or the idea they had and kind of bring it to something that when contractors or engineers would look at it and say, okay, this is familiar to me, and this follows everything that we normally do for other codes, and make it sort of a mainstream thing that can be used. So there's one thing to have an idea, but then to kind of bring it and bring the system to the final product was where we helped out this other company from France, to Vactech, to be able to do that. So they had the idea, but we had also the experience from our other lines of products, was from Total Pack and other products that we've done. So we were able to make it basically look, if you look at the Vactech system, it actually physically looks like a Total Pack with, we have the Viking valve, we have all the parts. So nothing in there has most of the parts are there already approved in a certain extent in other types of systems. So that was the big focus.
Now, when you approached all the, what are the listings that you guys have approved right now? Like where can I, if I were to get this project or I were to get a project where I want to put a vacuum system in, where is it approved to be installed?
Well, right now the approvals that we have are with FM. We decided to go to FM first for our approval listing, just because in the past we have a good relationship with FM, and also we know that they kind of come from an engineering background a bit more. So obviously, this not fitting into any box, as far as it's pretty different. So we needed an agency that would be able to kind of look at the whole project and say, well, look, we'll accept this if, here are the rules and here are what we need to test.
Yep.
And then have a kind of a testing procedure that they've developed for this.
Mm-hmm.
So that way we had discussion and we were able to kind of, set forth and get those approved and go through the whole process. But right now we're not funding FPA. It's not another code. So they had to kind of make up their own test protocol, if you will, for this technology.
So when you called, the FM, whatever submittal hotline, I don't know what the hell they have for that, but when you contacted FM and said, we're looking to develop a dry sprinkler system, and they were like, awesome, that sounds cool. And then you said, we want to use a vacuum. Were they like, was it, what? You want to use a negative pressure? Sprinkler systems use positive pressure. What do you create? Like, you want to use a low pressure? You want to use a low pressure? And then you're like, no, a vacuum. How did that conversation go?
Well, that conversation, I think FM, they were very open to the idea. Obviously, when we presented, we kind of presented facts, mm-hmm. and saying, look, here's what, here's why it's going to work. Here's why we've, done some testing prior to obviously presenting to them. Mm-hmm. We had them over for a few meetings, so it wasn't just one of those one meeting and done type things, but we had some discussions. And also, even with FM, I think they had an approach of, and I remember actually in the meeting when somebody had actually mentioned, let's learn to crawl before we start running. So obviously we had these, plan B, and we have all these ideas that we want to do now as well. But they said, let's just start from the basics. So we kind of started there and say, look, theory works. Let's prove this theory and then show us the system, show us the hardware. And so we kind of, built our way up from there. And no, I think they were very open to the idea. Again, the theory behind it or the physics behind it made sense to them. Mm-hmm. And so we just started going from there and showing them the system as well. And they were happy that we were involved as well, because when we showed them kind of the prototype that we had built, obviously they recognized all the parts that were being used. So at least that was a big thing for them as well. So on the hardware aspect.
So let's talk a little bit about the parts that are used in this. FireFlex doesn't have its own essentially dry pipe valve or pre-action valve. You guys are partnered, or like you guys partnered with Viking to get the right components for the systems?
Yeah, that's correct. Yeah, what we've done is we've used we've always been working with Viking since 1991 when FireFlex was created. So almost 30 years ago, we've been producing the total pack, on which we always use Viking parts right now. So we kind of kept to what we knew with the Vactech as well. So we ended up using the Viking deluge valve for the system. So even for the dry pipe systems, we still use the Viking deluge valve with the vacuum. So it functions as a dry system, but it's not the same quite, the valve. It's the deluge valve that we use. And we've kept, the same parts that we had for the total pack. So we try to keep it as standard as possible in what we knew for obviously a very good history over the years of those products. So we knew exactly what to expect. So we wanted to keep it as simple as possible and as familiar as possible when we could. Obviously, there's some things that we did have to develop for the vacuum, but in most cases, these parts were already available and already very reliable in the market.
Right. Now, touching on the components and stuff like that, you're using Viking deluge valves, things like that. My initial thought when I first heard about this, and I touched on it on one of the first 6 podcasts that I had done when I was doing them by myself, come a long way since then. I touched on what my opinion was on the vacuum system, and I thought it was a good idea, but I didn't know how it would work, especially with sprinklers. The reason being, when a sprinkler fuses under heat, the water pressure, the positive air pressure, the water pressure, etc., is what pushes the plug out. So that same technology that has been used since, the 1870s is no longer applicable in a vacuum dry system because it doesn't have positive pressure. What kind of challenges and what kind of development did you guys have to work with Viking in order to develop a sprinkler specifically for this system?
Well, that's a good question. And no, at first, actually, when we were presented the idea, they had a device to add to sprinkler to make it basically to force, like you mentioned, once the element fuses and to force the pip cap out of the sprinkler. There's an external device that was being used in Europe that they were trying out. When we approached Viking Corp with the whole concept, they had this new sprinkler design that they were already working on, and actually they had one out. They had their VK598, which was the large K25 upright, and that had a new design on it that had was kind of called, I guess, a flipper bit design or dislodgement device. And so when the element fuses, there's actually a kind of a spring mechanism that flips out the pip cap and throws it to the side. So this was actually done without knowing about vacuum. They were already moving towards this new technology for themselves, just for I'm assuming it was just for the dislodgement, or make sure that they were all, the performance and reliability would be even better. Mm-hmm. So they were moving towards this. So the timing was, in a sense, kind of perfect, because when we tested this new device with the vacuum, it worked right away. Mm-hmm. And we even, took higher vacuum levels, and we played around and tried to get, the maximum, and it was still working very well. So there's a lot of safety factor as well. So we were very happy with that design. And the good news is that they were already, in the process of changing over their line. So even today now, they have their new XT1 sprinkler line, has that new, dislodgement device incorporated into each design already. So as the new heads are coming out, they're getting them approved under vacuum with FM. And so as the production changes over, we'll have more and more options eventually. So right now, where we have, the three options, a K25, a 5.6, and a K8. Mm-hmm. But I know next year they have more coming out, and so on and so forth. So the timing was actually perfect. And when we had those discussions, that little smile on their face when we talked about that, because they showed us their plan a bit, and it was really coming together at the same time. So right. It's very fortunate for us as well.
Yeah, just where sometimes things work out for the better that way. Are there any other manufacturers that are kind of jumping on board with this and creating sprinklers that are going to be listed for vacuum technology in the future? Do you know of any that are coming out soon?
Not that I'm aware of. I know other people have probably looked at it or talked about it. I know have people talking about it, but I haven't seen anything or not aware of anything particular right now that somebody's trying to achieve that right away. Mm-hmm. But I know right now it's Viking, because I know they're changing their line over to it, but not to my knowledge, no.
Okay, no, that's good for Viking to have they've kind of essentially cornered the market the same as you guys have with the Viking or with the vacuum technology. Special applications. This I'm assuming, well, maybe not assuming, but was the product developed for a specific application in mind, or was it kind of looking to change the way that dry systems are looked at?
No, there wasn't a particular application. I think mostly, like you mentioned, it was mostly for dry systems, but also we do pre-action. So, single, double interlock, non-interlock. So that's good for all of those types of systems. So there was really no specific application in mind. I know that originally when the company Vactech actually approached us, they had a few customers that were looking more at warehouses and unheated buildings as well was a big advantage. So they wanted to be able to do that. But it doesn't, for us, it's not there's not one particular market necessarily. It's good for a lot of things. So I think it's just the fact that instead of, pushing dry, moist air into a pipe now, we have an alternative to go the other way and then, pull a vacuum, supervise your pipe, and do the same work, but with other advantages.
Looking on your website here, going through kind of the general product descriptions on the website, which is www.fireflex.com if you want more information. It's noted, and it's got a couple little ticks there for more information required. The possible use of gridded dry systems. That's an interesting one.
Yeah.
So explain to me how the entire history of dry sprinkler systems, NFPA, FM Global, everybody have been no dry gridded systems. I'll figure it out eventually here. No dry gridded sprinkler systems.
Yeah.
How does vacuum technology change that ability to create a gridded dry system?
Well, again, for us, and when I'm trying to be careful and cautious when we approach the subject, because I know that it always creates discussion, which is good, and which we want to have. So right now, that's not approved, and it's been kind of like you said before. It's always been no, you can't. But now we're trying to just have that discussion to show, because the idea about vacuum is that, and maybe the simplest way is to kind of explain it. Let's say you have a single interlock system, so meaning you have a detection system and no heads open. So if you're using a single interlock and the vacuum system will activate, what happens is that we actually fill up the piping about 90 to 95% full of water everywhere in all the branches. So as the system's kind of just sitting there, it's mostly filled with water. There's a bit of air. So the idea about gridded systems for dries is obviously you have a lot of air to evacuate before the water gets to the sprinkler head. Mm-hmm. But with the vacuum, what we do is by filling up at 90% full of water, is that if you have a design where you have your main pipe and you have your cross mains and then you have your riser nipples, mm-hmm. at 90%, usually you fill up your riser nipples full of water. So all you're doing is you're trapping that last 10% of air into the branch lines only, certain branch lines. So yep. The idea is that if one sprinkler opens, you're evacuating a little bit of air, and then water's coming out of that branch line. And then as soon as the fire spreads and moves to the next branch line, well, then you're also evacuating a little bit of air, and then water's coming out right away. Conventionally, if you did that in a standard dry system where you had this huge air pocket, then each branch line, they're kind of like in parallel, like a big volume. So now you're emptying out a lot of air before water actually comes out. And so that's the idea about having vacuums, that you're actually filling up and stopping from having one big air reservoir to many small ones only on the individual branch lines to a certain extent.
Okay, so I was always under the understanding that the reason you could only have treed in looped dry systems is because the lines that are not have not fused with sprinklers, the positive air pressure is not going to evacuate from the system. It's going to kind of stay as a cushion, and so that the water doesn't have to fill up every line as you get closer to the inspector's test. Now, obviously, with the low pressure the low pressure dry systems, et cetera, you're not going to get that as much. But that was always what I assumed. That's how so I just learned something right there. That's good to know. Huh.
Well, that's the idea, and you're right. Normally, that's why the tree system, and that's kind of one of the other reasons too that you said, vacuum is quicker because you're pulling in water, which is not quite accurate, but you're not also creating a restriction. But the idea is that with vacuum, you're actually filling up more of the pipe before you get to that furthest head. So that's why when the original tests were done many years ago, we were doing inspector tests, and we're saying, well, the arrival time of water is not faster but that was the main goal. But if you think about it, most of the water was filling up all the rest of the piping meanwhile. So that's why we're saying in some cases it can be quicker, because depending on how you design it, if you have a long main pipe, it'll go quicker. But if you have a big tree system, water is going to go everywhere. So again, it's just a bit of a change in philosophy there. So you're not bringing it really fast, because you're right, air is compressing to the branch lines and your water is going to the furthest point as quick as possible. But then when you hit the next branch line, you still have to evacuate all that air before water comes out. Mm-hmm. The difference with vacuum is that now water is already at that next branch line as well, ready to go, and so on and so forth. So yes, sometimes it's not quicker, but then water is there after that everywhere else. So it's a different way of looking at it, and that's kind of the discussion that we're trying to have right now with the industry, and see, well, what's better, to have quickest water or have water everywhere ready to go, and have smaller pipes as well. Because if you do gridded systems, in most cases, then you could probably hydraulically do it a bit differently. But again, it's just a major change in philosophy, and so we understand that's why we're taking a calculator cautious approach to that statement. But FM, when we had those discussions, again, did agree on the theory part, and I know that they're supposed to look into doing a research program just to kind of, maybe corner a few of, of the rules of thumbs that we could use or move forward in time. So.
Yeah, and what a lot of the manufacturers, I don't know if you're on the same page as well, but competition is good. So I don't know. Is this a patented product with you guys right now?
The vacuum itself is the idea of vacuum is sort of patent. It's not it can't be patented as far as creating vacuum.
Right.
But all the parts that we're using on the system, yes, some of them are patented already.
Okay, that's just curious to know there. That's it's a good technology. Yep. I think it's going to be interesting. Like I said, the industry's evolving so fast over the past 10, 15 years. It's good to see all these new kind of products coming out and learn more about them. A couple of the questions actually I have for you. You guys are essentially going to have to assist NFPA in creating a new. It's almost going to have its own section in NFPA 13. Will the fill rates that are required for NFPA 13, half an hour fill rate, 60 minutes for a freezer, are those fill rates going to be the same? You have 30 minutes to get to the negative pressure that the Vactech system is set for?
Well, I assume like in NFPA 13 for sure there'll be some places where that's where we have to start working on and seeing exactly all the places. But the 30-minute requirement for creating, in this case, the pressure for us, I mean, even if it was the same, it's not a big issue. Right now, we're actually doing a lot better with the vacuum pump that we chose is very. It's a very robust industrial pump. So right now we can actually create vacuum in a 1,000-gallon system in 4 or 5 minutes. So it's actually quicker to start up a vacuum system than it is a pre-action right now.
Yeah, absolutely.
So that for that aspect, it's not a big problem. But for sure, as far as like you said, grids and all of that, that's going to be definitely a major change that's going to be addressed and looked at.
You guys are going to have to put a notion into NFPA to get a change it from a fill rate to a set pressure rate, right? Because the fill rate is an air compressor compressing the air in a system within 30 minutes. You're going to have to remove that. The way they explain it and the way they word it, it's going to have to be changed, because if you guys only have to get to so what is the pressure that it activates at?
Well, right now we're talking in millibars, just because the numbers make a bit more sense. But if so, we're talking about minus 130 to minus 150. So right now we're at minus 180 millibar to 150. We're in supervision mode. Then we're into a sort of at 130 millibar. Then we open up the valve and send water. So that represents about minus 2 psi, let's say maximum. In that range. So we're very we're at negative 2 psi.
Negative 2 psi is you should
vacuum,
get down minus 2 psi pretty quick for the set pressures there. It's Is there anything else? Is there anything else that I'm missing about the product? It's a very interesting product, and it's essentially it's fairly new to the market still, 2 years in. How is it selling? Are people accepting it and using it in applications right now?
Yes, we have. Well, we have sold some systems, and most people that we've seen, everybody is very excited about it. I think everybody we have very good feedback and good responses from everybody. All those that we've shown and kind of shown also, because we do have some demonstrations even here in our factory where we have plastic piping, kind of showing them how it works. And everybody that leaves and sees that are very impressed, and they understand that, okay, this makes sense, and so they're very happy. So we've done freezer projects mostly right now because of, again, what's limiting us right now is just the heads that are available. I know that they're coming out. So the first one that was available was like the VK598, which is mostly used in freezer applications. So that was the first head that was out. So with that now, we've done quite a few freezer projects already. And we've gotten very good feedback from the contractors who installed the system. Again, they were amazed at how quick it went to create the vacuum and get everything ready. We've also done storage applications. Again, some in Europe as well, some high storage applications. We even did one that was a bit different. There's an anechoic chamber as well here in Canada where they have these telescopic drops that come down from the ceiling in a single interlock fashion.
Yep.
And they needed something that was they had to have very low pressure because obviously if too much pressure, these telescopes would kind of be down already. So with the vacuum was the best scenario for them. So the cage stayed up, and as soon as detection kicks in, then the water comes in, and all the sprinklers come down from the ceiling, and then can operate if needed. So we've done one of those as well in up here in Canada, and worked really well.
That's awesome. That's it's good to hear that new products are being accepted there. I keep thinking of these questions kind of as you're talking and stuff like that. Is there any difference in the groove coupling that has to be used for this installation? If you're using groove fittings, things like that, is it a different coupling?
Nope, not at all. Actually, when we first started out the approvals, we went through with FM all the testing of all the different couplings. So we actually used a bunch of different common manufacturers, and we sent them in to get them tested to make sure. And then FM then realized that they actually do vacuum tests on all the couplings anyways, and the vacuum levels that we're talking about were pretty much the same as what they were already doing. So as of now, any approved coupling already has this kind of built-in vacuum test that's done on it, and it works for us as well. So nothing different in those regards. And actually, some of the questions we get from contractors, well, is vacuum, does it leak more than air? But no, we haven't. At -2 psi, we haven't seen any difference. And actually, some projects we've done, because on our FLX PC or FireFlex pressure controller, we monitor when the pump starts and stops and how long it does that. And some systems have been out, let's say, for a year, and it hasn't even started almost once. So, meaning that the pipe is very tight and the system is very tight, and it was installed, like in a normal fashion. So it's not prone to leaks more than another air system or anything else.
Awesome. Another thing I thought of there, kind of while you were talking, the vacuum. Does it shut off at say 180 millibars, 2 psi? Is there a fail-safe on that? Like, what would happen if that, if an air maintenance device on an air compressor fails, it's going to pump to what the air compressor is listed for, right? And it's going to keep pumping until it possibly blows.
Yeah.
If the vacuum is there a fail-safe on the vacuum where it could possibly get like a -15 a minute, a -50 suction on that pipe?
There actually two safeties. Yeah, so there is one on the pump directly. So if the pump for some reason would go, it can go below a certain value, and also we have one on the network right after the valve as well. So it's the same idea. So if it goes past a certain negative value, and then it's set, and it'll open up, letting air in, so that it'll kind of, it's a vacuum breaker, so it'll break the vacuum if it gets too high. But even the pump that we do use, I mean, obviously in vacuum it's a bit different. So the absolute vacuum, like in space, is like -14.7 psi, right? So our pumps aren't that strong either. They can't go to that kind of vacuum. But we do have a vacuum breaker. We actually have two in the system to make sure that for some reason the pump, loses its mind and tries to go higher, it can't. And on the network itself as well, we have one that was added to. So no, you can't go higher up. And obviously there's a lot of safety factor built in. Even the sprinklers can open with a higher vacuum than what we're using right now in all cases. So.
Jonathan, thanks for coming on the Fire Sprinkler podcast and talking about the Vactech system from FireFlex. If anybody wants more information, where can they get more information from you?
Well, you mentioned before for sure to go on the website at fireflex.com. As well, they can find us on LinkedIn or on Facebook as well if they have any questions. And we have a question section there, and they can reach us, and we'll be more than happy to help them out and answer any questions that they could have.
Awesome. Jonathan, thanks for coming on again. If you have any videos or anything of the product testing or anything like that, send them over to me. I'll share them on my social media, and hopefully we can get a lot of people to not buy in, but to see the Vactech technology, the vacuum dry system technology, and very, very curious new product out there from FireFlex. Thanks for coming on.
Well, thank you for having us on, and for sure I'll send you the information.
Hey everyone. This episode of the Fire Sprinkler Podcast is done. If you liked this episode, leave a review, comment, or hop over to my social media pages and let me know. Just search Fire Sprinkler Podcast on Facebook, Twitter, Instagram, or LinkedIn. Don't forget to hashtag Fire Sprinkler Podcast and anything you think I should know about or see. If you have any suggestions for future episodes of the Fire Sprinkler Podcast, email info@firesprinklerpodcast.com. Thanks for listening. We'll see you next time. Take care.